Okay, the next two constructions we're going to do are on the centroid and the orthocenter. Both of them could come up in coordinate geometry, and both of them are very, very similar, so you could easily mix the two up. It's really important you go through in detail the difference between this one and what we're going to do in construction 22. Construction 21 is if you're asked to find the centroid of a triangle. The centroid is the point of intersection of the medians of a triangle. And in a triangle, a median goes through one vertex and goes through the midpoint of the opposite line. I've written it here that a median goes through the midpoint of a line and its opposite vertex. So I have to identify the midpoint of the line and then go through the opposite vertex. If I identify two of the medians in a triangle, the point of intersection of the medians is the centroid of the triangle. Supposing I was given the triangle ABC, I might be asked to find the centroid of this triangle. We only need to explore one scenario here. It doesn't matter whether a triangle is acute, obtuse or right angled, the centroid will always be inside the triangle. The centroid is the point of intersection of the medians. And as we've just seen, the median, it goes through a point and it goes through the midpoint of the opposite line. So I need to, the first median I'm going to find, it goes through A and it goes through the midpoint of BC. Then I'm going to find the median that goes through B and the midpoint of AC. The problem with this construction is, how do I identify where the midpoint of a line is? So the first thing I want to do is join A to the midpoint of BC, which means I need to identify the midpoint of the line BC. In order to identify the midpoint of the line BC, I need to carry out the construction for the perpendicular bisector. One of the constructions, and it's the one that we used for the circumcenter and the circumcircle previously, one of them that we used allows us to get a perpendicular bisector of a line. In other words, it allows us to draw a line that is perpendicular to BC and bisects it. The fact that it bisects it means it goes through the midpoint. So I'm going to construct now a perpendicular bisector of BC, but not because I want the perpendicular bisector, but because if I identify the perpendicular bisector, I'll also identify where the midpoint of this line is. If I identify the midpoint of this line, I simply join it to A, and that's one of my medians. In order to construct a perpendicular bisector of the line BC, the first thing we're going to do is place our compass at B. Measure an arc that is roughly 2/3 of the distance from B to C, and then draw myself an arc. So once I placed my compass at B, I simply drew an arc that was roughly 2/3 of the way from B to C. Now you keep your arc length at that exact same distance, place your compass at C and draw another arc that intersects your original one. So my second arc intersects the original one here and here. The distance from B to the first arc is the same as the distance from C to the second arc. In order to construct the perpendicular bisector now, I simply need to use a ruler to join up these 2 points. So the line that I've drawn in black here is the perpendicular bisector. Now I don't want the perpendicular bisector, but I'm concerned with the characteristics of a perpendicular bisector. It's perpendicular to the line BC and it bisects it, so it goes through the midpoint. So now I know that the midpoint of the line BC must be there, where the perpendicular bisector intersects BC. So now, if I just take A, which is one of the vertices, and I join A to the midpoint of the opposite line, that is a median. So that'll be my first median, which I'm going to use in order to identify the centroid. So when I join those 2 points up, the red line here is my first median. Now, once again, I'm going to eliminate my construction lines, although obviously you need to keep your construction lines there. If I eliminate my construction lines, I'm left simply with the median, so it goes through A and it goes through the midpoint of BC. In order to identify the centroid, I now need to find another median. So what I'm going to do now is I'm going to draw the median that goes through the point B and goes through the midpoint of AC. But in order to do that, what I first need to do is identify the midpoint of AC. And in order to identify the midpoint of AC, once again, I need to get a perpendicular bisector. So I'm going to place my compass at A, measure an arc that is roughly 2/3 of the way from A to C, and then draw myself an arc. So I placed my compass at A and I drew myself this arc. What I'm now going to do is keep my compass at that exact same distance, except place my compass at the other end of the line. Place my compass at C and draw an intersecting arc that intersects the blue line twice. So I've drawn my second arc now. The distance from A to the first arc is the same as the distance from C to the second arc. If I join up the points of intersection of the two arcs, that will give me the perpendicular bisector of the line AC. So with my black marker, I've drawn in the perpendicular bisector of AC. But remember, I don't want the perpendicular bisector. What I want is the midpoint. The fact that this is a perpendicular bisector, that's not what's important. It's that this line, the black line I've drawn, goes through the midpoint of AC. So I now know that this is obviously the midpoint of AC. So to come up with my second median, I join up B with the midpoint of the opposite line. And that will give me my second median and allow me to identify where the centroid is. So I've drawn a second red line, and this second red line joins up B to the midpoint of AC. So now I've come up with two medians for my triangle. And I'm going to eliminate my construction lines so it's easier for you to visualize what's going on. When you've identified your two medians, you now know the point of intersection of the medians is the centroid. Now, you'll notice that up here I've marked in something about the centroid. The centroid is the center of gravity of the triangle. So in an exam, you could be asked to find the center of gravity, and that refers to the centroid.